Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter. Last time we mostly finished the for next loop, and this time I want to focus on GOSUB and RETURN, which is a pretty primitive procedure calling method in BASIC. All right, so I don't know if you've run across it, but it works like this. So here we have a small program, 100 x equals 21, 110 GOSUB 2000. That says find line 2000 and start executing there. And when you hit a return, come back and execute the line after this one. So we'll set x equal 21. We'll go down to 2000, print the x, assign y as 2x, so 42, and come back to 120 and print the y. Then we'll go to line 130, x is 10. We go down to the subroutine. We print 10. Y is twice that, so it's 20. We return and execute line 150, print y, which is 20, and then 999 end. Program stops running. Okay, and so the subroutine is down there 2000 to 2020, and it's got that return statement that tells us it's over. Now in the original BASIC, you weren't allowed to nest subroutines, so line 2010 could not be a GOSUB to a different subroutine. Later BASICs removed that restriction pretty early on, and we'll go ahead and allow subroutines calling subroutines, but we won't allow recursion and we won't detect recursion. So also the way most of those basics worked. We could, because we can track and see where which routines have been called and where they are, but it's overhead we're not going to bother with. All right, but first, I realized we had not checked nested loops, and we have a long test that gave us a bunch of trouble last week, just trying to debug it in BASIC and Swift at the same time. Test multi-D array full read and write. So the goal there was writing numbers into a 2D array and then reading them back out and making sure everything had a number in the right place and so on. All right, so let's start there. Okay, back here. So here's test multi-D, and also I searched for nested, not found. Okay, so let's see. So I equals 0, I greater than 2, 220. I is 0. Okay, so I'm going to assume this is a for loop for I equals 0 to 2, since greater than kicks out. Okay, and then 220, well, let's put it at 210. Next I. Okay, so I think I can cut out these two lines. And somewhere I have an I plus 1, yeah. Okay. Go to 25. Well, I'm cutting that out too. Okay, so let's make that 110 to conform to what we had. Okay, so for I equals 0 to 2, next I, and in there we do a J loop. So let's say for J equals 0 to 4. Okay, J greater than 4, 100. Okay, so that was our increment on I, so the next. Okay, so let's take that out. X equals X plus 1, we're keeping. J equals J plus 1, we're not. And go to 40 becomes next J. Okay, let's see how that looks. For I equals 0 to 2, for J equals 0 to 4, B sub I J equals X. X equals X plus 1, so we're starting 1 and writing successive numbers. Okay, and then we printed them, and they should come out in order. All right, we'll fix the second one first. I just want to make sure this one runs. And unfortunately, I didn't run the test once before, so we're doing a cold start. Excuse me. Okay, all tests passed. Okay, so we can do the same thing, which is doubly good because our nested for loops work. Okay, so this one is also for I. Basically, it's the same two loops here. for I equals 0 to 2, for j equals 0 to 4. We don't need that one. Don't need that one. We're just printing next j. Okay, and then we don't have any go-tos anymore, so it's okay to renumber things a little bit. 40, 60, let's make this 70. And then do 20. All right, so let's go ahead and throw a rem in there. Okay, just to space it out a little bit. Okay, and run this test. All right, good job. I guess I should be doing this in my to-do. I never wrote it in here somewhere. Yeah. That's what we're really doing. Okay, but now we're checking in. Make test multi-d function right. Use nested for loops. And that sort of says it would have been nice to do for loops before we got to the array stuff, but that's okay. All right. Today's the 14th. Yep. Okay. All right, now let's tackle GOSUB-RETURN. All right, so the first step in any of these is we want to make sure that the keywords are there. So GOSUB, go to the subroutine and return. I see this. We have these few keywords that are matching regular keywords. What we've done this before. So let's rename this tick if. Whoops. Rename this. I gotta start using my control keys consistently on this. Went to all that trouble to put them in. Okay. I'm just trying to put a little more consistency in how we're naming things. Okay. Rename tokens to use around Swift keywords. All right, but the question we had was, does it handle GOSUB and return? And the answer is yes, it does. All right, and let's see, back here, all we need, return doesn't take anything, and GOSUB just takes a line number. So let's look at the parser. Well, let's look at parse. Okay, I don't see GOSUB or return here, so we pretty much don't handle it. Okay, so yeah, here's this big case, and I'm kind of thinking this should be alphabetical just to kind of smooth things for us a little. So I'll just, since we're in here looking around. Dim4. Okay. Nothing dramatic, but just I like to make these little tweaks when I'm forced to be in this section anyway. All right, let's start a parser test. Okay, we'll just, well, I guess you could make the same argument there, couldn't you? We'll put them down here. And maybe these tests, I don't know, maybe that I'm not comfortable that my tests are, 600 plus lines and not done. Okay, so let's test GOSUB requires line number. Oh, well, I guess we want to say, let's just do normal GOSUB. Okay, check program parsing. Okay, and we'll say 10 GOSUB 20. And we expect to get back a GOSUB of 20. All right, which doesn't exist. Better not exist. Okay. And I guess by the same argument I made above, I might keep that error case up there and skip go to if. We're getting enough cases that it's becoming a challenge to find the right one. Okay. Assign def dim4 go to if and okay. And we wanted to add GOSUB of the line number. Whoops, parser test. All right, so this test should fail. And it'll compile because we don't okay. Parse says no member GOSUB. Oh, statement. I guess I need the whole line thing there, don't I? We changed that a little bit. Yeah. And this one, yeah. Error end case GOSUB. Interpreter error dot can't. Well. It's kind of my default not yet implemented. All right, run tests. We expect one failure. Test GOSUB. Okay, we get back some sort of unknown statement error. All right. So our parser. Now our token comes in is GOSUB. So let's do that. GOSUB line number and try GOSUB. Put that over here. Func GOSUB throws returns a statement. There. Okay. And so we know we need to do next token. And then it's almost like GOTO. If it is an integer, we're good. Integer line number token return GOSUB. And otherwise, we want to throw an error. And we're spinning off a test obligation is the language I use now. The other day started. You know, my test covers this part, but it doesn't cover this part. But as far as I know, the only way I can find that I can check this part easily is by using this if case structure to match the token, in which case you have to cover the case of what happens if you don't. So this and was just not there yet. So I'll just mark it like that. Okay. And maybe in here, well, let's see, we're doing parse GOSUB, and then we also need to check that line number or error if line number not present, something like that. Okay, I think that'll be more accurate to what we're doing. And I think this should pass. Well, pattern with associated values. Oh, right. This is the token. I got to keep those straight in my head. So token is just the keyword. It has no associated values. Okay. And I didn't try and pass it in here, but later we'll probably pass it. Okay. This, and I don't know, I think I'm better off making things more consistent than less. Okay, that passed, and test function test GOSUB requires line number. And if we have 10 GOSUB, we expect missing target of GOSUB. Okay, and let's make another one too. If they try to do GOSUB X, like treating a variable as if it can have a target, that's not allowed in BASIC. At least these old basics should fail just because of my message. Not equal to parse line number, target GOSUB. Yeah, just my X's. Okay, and then I think, let's see, our parser. Well, we handle a GOSUB, but we don't handle a return. Okay, so let's add some tests for return. And it's almost the same kind of thing. And let's make the error return X. And I think the text, I think this one we get for free. The text will be different. So this is return stands alone. I don't know. Return parse return 20. Is that a keyword? Okay. And statement has no return. Now it is a keyword. Okay. Okay. And then we know it's going to complain about our interpreter. Okay. Oh, no parens. Okay. Yeah, we got unknown statement and unknown statement. That's fine. Okay. This is switching on token. And again, I'm just kind of pushing things a little more alphabetical, but we'll clean it up in a minute. Return statement. Throws returns statement. Okay. Come in with return. We skip over it and return. Is that what we put in statement? Yeah, no arguments. Good. Okay. And I think the error case is caught up top. And so we'll tweak the message in the test. Okay. Extra characters at end of line. Yeah, that's a perfectly good message for this. I guess I'm not keeping up here. Parse GOSUB. Okay, those, make sure they all pass. Okay, so you can see, I mean, we've got a lot of mechanism for parsing in now. It's pretty quick to add that. All right, but now we got to do the interpreter part. Yeah. Oh, let's check this in. And actually, I want to pause and just do a little test cleanup in here. Yeah, I don't think these tests, when we check the parsing, I really don't want to talk about the parse. I want to talk about the statement. Okay, so I'm gonna. I think we need a test for the line number to make sure it's there. Okay, yeah, and I think these are fine in that sense. Check expression, check parsing. Mostly, I'm gonna copy this part. Basically, I'm inlining these. Okay, parser equals parser. I'm gonna say XCTAEQ. Okay, the program is this. And it should be equal to this. Okay. And I think, yeah, same thing here. Q. Parsing that should be 9999 end. Let's make sure that's good. Okay. And then the check error, I'm good with that. Okay. So I think the thing I want for check parsing, I want this. Okay, so tell you what I'll do. I'm gonna make a new one that's check error, check statement. And it expects back a statement. And then expected, I'm just going to do result.statement and pull it out of the result and ignore the line number. Okay, and I think I can use that one. Okay, so if I call check statement and just return the skip. All right, that should be okay. All right, and so I can fix these one at a time because I've set up the parallel structure with the other method there. And that's a good thing for me, not breaking everything all over the place, because we got 600 lines, about 5 each or something. It's a lot of tests to be playing with. And just make sure we're still on track. Hey, let's see. Hey, good to see you. We're working in Swift and we're writing a basic interpreter. So I'm going for I've got the original basic description from 64 and then this 8K basic from 78, I think, and Commodore 64 from 80, 84, 85, something like that. So kind of 3 basics, kind of weaving between them. All right. And just kind of cleaning up our tests for now. There's a book called 100, I think it's 101 Computer Games or something like that by David All from way back when, probably in the 60s or 70s. Yeah, before my time, right? It's got some cute little games and stuff, and there's a real nice, clever maze generator, and I want to get that thing running in this as kind of a proof of concept here, or proof of actually interpreting things, I guess. And the second thing is I've got a refactoring that says if you have an interpreter and you want a compiler, do this. And so I wanted to pick something that was big enough of a language that I could have that kind of challenge for the refactoring. So I think the refactoring is probably a couple weeks away, but we're closing in. We've done all the expression stuff, and we've done the for next loop yesterday and a little bit today, and we're working on GOSUB, and there's not a whole lot of statements left. There's ON-GOTO and ON-GOSUB. I guess I should list that separately. ON-GOSUB. The newer basics allow multiple statements per line and multiple statements after a if-then, but that's not in that original basic. And at that point, everything else is kind of quality of implementation stuff. So in Swift they have enums, and the enums can take extra arguments and they can be recursive. So like here we've got, I guess this one's more demonstrates that. So if I have case missing, case number, I put dot missing as the name of the thing. I could also say expression dot missing. But here I've got expression contained in expression. So this can build trees of stuff, and pretty complicated in that sense, or powerful in that sense. Yeah, it's kind of on that ADT line. You can put methods on them as well, so they're pretty complete and pretty useful that way. I don't think I'm a perfect user of them, but doing stuff like this to build up little trees and things like that, it's very, very simple. I guess if you know functional languages, some of them have done that sort of stuff. They talk about sum types, that this case plus this case plus this case plus that case, as opposed to a struct where you got fields and you're multiplying the possibilities, So this one adds more possibilities. All right, let's go back to our tests, check parsing. Yeah, you popped in right at a mindless moment here. I just want these things kind of expressing, kind of the bare minimum of what they're really looking for, because there's just so much mechanism. Okay. I've looked at it just the tiniest bit, not enough to really learn it or anything, but that's a nice language feature. My Xcode was crashing yesterday like multiple times, and I installed AppCode, but I haven't played with it in a while. But doing this kind of stuff and watching it not really help too much on the editing makes me miss it. Miss IntelliJ for Kotlin or whatever. And, since I put the parse thing in just like yesterday, I think it would have been better to see this then and not be revisiting, but oh well. Expression statement. We're getting close. How are you liking Rust? messing any up. Oh, good. Yeah, maybe I'm lazy, but I really do appreciate the good tooling. I know it's not really lazy. It's well, you just hope it gets added. I think C++ did good things, but one of the bad things it did was it was just so complicated of a language and so hard to parse and so hard to do. It really kind of stopped the tooling. It just took a long time for any real decent tooling. And, it's like the compiler companies, they can only invest in, certain amounts. And if you want a big language, it's going to take longer to get good tools. Not that Swift is so tiny. Oh, good. Nice. Did I get... That was so fast. No, I got to build failure. Okay. And now at this point, nobody should be calling check parsing. Symbol. Okay, so let's get rid of that. Yeah, I don't know. It's been a while since I had to use it. I have used it with groups. I had one group I worked with. They had decided a big project to convert to C++, and they had taught all the programmers C++, and they had been implementing this big project for a year, I don't know, more maybe. And they brought it up in production kind of environments, and it was falling over all the time. And it turned out that people had just not caught on to the way you had to do memory management in C++, and just had this kind of disastrous thing where practically everything was not managed in terms of memory, and you just can't do that with C++. I mean, it's more possible now with the templates and all that stuff in better shape, but yeah, it's a tough language to learn. It's very large. I don't know. Yeah, C. But yeah, I mean, it's just one of those things. They learned. They got through it a year or two later. They got there. All right. Let's see. So we've done all that. So just improve, or let's say simplify tests. And that really was a refactor. Okay, so we've got you have to do the lexer, the parser, and then the interpreter itself. And I got one more cleanup. Well, I don't know if I want to how I want to do this. Ugh. It kind of like this stuff. We just happen to do print statement first. I kind of want to get these a little more alphabetical. Type 4 is really a helper. I don't think I have to do the whole thing. I'm just going to do a little bit here. AD, get it a little closer. Okay. Yeah, I don't know. This just grows because we're doing the parser and some semantics in here, and I'm doing this recursive descent approach. So it requires that you have methods for each grammar rule and stuff like that. All right, but it makes it on the large side. Okay, so here's 4. We'll stick our GOSUB after 4 next. Well, yeah. Test GOSUB. Okay, so we're going to write a little program that uses GOSUB 10, GOSUB 100, 20 end, 100, print 42, 110 return. Okay, and if you did this, you ought to get a 42 out. And this is kind of the simple version. Yeah, that'll be enough to be interesting. I'm starting to think about what can go wrong as well. So let's see, is my to-do interpret GOSUB-RETURN. Okay. Yeah, that's kind of what we're doing still. All right, this should fail because we don't handle GOSUB. We get NYIs. Can't happen NYI. Okay, line 10, the GOSUB. Alrighty, so GOSUB. Basically, our structure is just do something. Let's do GOSUB, and this is the line number here. These methods can throw exceptions, so we'll just assume they're coming along and doing that, and then we just return the output. So I'm not particularly happy with how I'm handling the output, but basically GOSUB is a statement. It doesn't print or anything, so it doesn't affect the output. All right, so well, let's find do go to. Okay. I guess GOSUB can fit in front of it. Doesn't return anything. Okay. All right. So the implementation I want to do is basically to have a stack of return addresses. So when we want to call somebody, basically we're gonna push the next line on the stack. I guess I'll call it the return stack. On the return stack, and then we're going to go to the subroutine. Okay, so we're a level deeper. You know, it's kind of this is the kind of thing a compiler has to do when you call a function. Usually there's often a assembly language instruction that handles going to the subroutine and maybe even pushes the current line number, return address or something like that on the stack, but we'll have to do something like that. Okay, so let's create a stack, another stack, because we have a small stack for go-tos as well. All right, but let's make a return stack, and this is just going to be line numbers. Starts out empty. Okay, so the next line number, let's see, I think it's just program.next line number. Oh, line after, okay. So if we want to push the next line after this, so we'll take return stack dot append the next line number. Okay. And we'll do a goto. Do goto of, let's call this subroutine line number. Line number is the global line number we're tracking. So this is subroutine line number. Okay. And the return statement, let's push that in here too. Find the case statement for this thing. Okay, there we go. Return, we're going to call do return. And return the output. Okay, let's see. So the return statement, basically we've got this thing on the stack and we're going to pop it and jump back. Okay, so let return target, whoops. Return target equals return stack dot, okay, they do a pop last. Okay, and for the moment we'll just assume it's going to be there. Okay, that's a potential error, so let's note that error. We might have to worry about what if return stack is empty on return. Okay. Oops. All right, so return target, we pop the thing off the stack and we just go to return target. All right, and the fact that I'm even using a stack, I'm reaching ahead a little bit for that, I guess. But let's see if our test passes. I think it should. I'm about 1 for 3 on that call. Okay, yeah. All right, now let's worry about that case. Let's handle an error case. Return without GOSUB. So if somehow you check expected error. If you just said 10 return, and that's the first thing you tried to execute, we expect some sort of error. Return called before GOSUB. Something like that. All right. And we're expecting most likely a stack will blow up. Because right here we said it's going to be there, and hey, there it is. It's not. Okay. So if return stack is empty, there's a way to do this with a guard, but we'll error. My text return called before GOSUB. Okay. I guess I could do that. I could say guard not return stack is empty, else that. Okay. And I expect this to pass. Oh, hey, Rick. Yeah, hope you're well too. We're doing GOSUB-RETURN today, so we've just got the basic GOSUB working. You GOSUB to some line number, it goes down there, runs till it hits return, and then jumps back to the statement after there. You know what? I'm gonna add another line to that task. Well, let's make sure this one's. Oops. Oh, we need the line number. I'm just going to add another print just to make sure that everything is good. Okay, so our error message is good. Print 52. And just making sure we get back to the right place and do something and didn't just like exit weird. All right, but I don't anticipate a problem with that. Yeah, so one thing I noticed, the original basic GOSUB is one level. Your subroutines can't call subroutines. The later basics kind of lift that restriction, but they don't allow recursion. And you don't have parameters, you don't have local variables. So it's about the most minimal kind of subroutine mechanism you could ask for, I guess. Okay. GOSUB return for single level GOSUBs. Okay, so we dealt with that one. Let's make an example. Test GOSUB in subroutine. We're saying that should be legal. Let's make sure it is. Um, 100. Print 100. Let's mix them up a little, make sure it doesn't matter if it's forward or backward. GOSUB 50 and okay. So language is not really great, is it? Okay, GOSUB 100 and then print 20. So 100 will GOSUB 50, print 50, return. I guess we already printed our 100. So we print 100, print 50, and then print 20. All right, and so my expected value I guess I didn't make my procedure call. So I guess 100, 50, 20. I'm debating if I want to put more complexity in, but I think that's enough. All right, yeah, so because we had the stack, when you go sub 100, it pushes 20 on the stack, the return address, as it were. And then you get here, you print, you go sub 50, it pushes 120 on the stack. So we got 120 and 120. Print, return, pops and goes to there 120, which pops and goes to there 20, and then prints. Okay. Well, let's say including nested calls. No, I don't have to say what if. It's really just error. Okay. Anything else with that? I don't think so. It's so much simpler than that for loop. Okay. All right. Well, we've gone for a while. Let's just take a 3-minute break. I'm just going to grab a drink and we'll come back and tackle this. I guess the thing I'm looking to is this thing's going to create problems. So you can say if 1 equals 0, then 20, and then you sort of have an else that's like print 30. Okay. This becomes legal with multiple statements on a line. But now imagine I did this GOSUB 100 print 30. I got to return. Where's my return value? Well, I don't want to go to line 25 that happens to be next. I want to return here and do the print. So this is going to create some more complexity in line numbers, but these two are used in real programs, so I want to get them in. Multiple statements is a bit of an extension past that original basic. All right, so anyway, let's take that 3-minute break. It'll be back top of the hour by clock anyway, and see you then. All right, welcome back. Let's see. So this on-GOSUB, on-GOTO stuff. I don't think it's in this old original basic. Unfortunately, this is not a searchable text. But yeah, I'm pretty sure it's not there. It was added by these later ones. Statements. Yeah, on-GOTO. Okay. So on-GOTO is there. I don't see an on-GOSUB. Let's see if it's in here. This is Commodore 64, and this part's alphabetical. On-GOTO or GOSUB. Okay, so yeah, I guess you can see these mechanisms kind of evolving as they go. So they added on-GOTO. Well, let's start there. So if you do that, it evaluates this expression, and then it goes to it figures out if it's 1, it goes to this one. If it's 2, if it's 3, and they don't tell you what happens if it's not. Okay, let's see what happens. Negative illegal quantity. Ignores the statement and just continues on. Oi. Okay. Well. All right. We'll have to make sure the word on. So again, where's my picture of this? Yeah. So interpreter structure, you do lexical analysis, also called scanning or lexing. That's our tokens. So we have a lexer, it produces tokens. The syntax analysis or analyzer does the parsing and turns the stream of tokens into a tree of nodes. And our nodes that's the statement and expression stuff. So those nice little enums. And then the interpreter takes the tree and walks it and takes your input and output and, runs the program basically. And so when we go to a new kind of statement, we just walk through and make sure, do we have the tokens? Do we analyze it? And do we produce a node for the interpreter? Okay. And let's see. GOSUB. Okay, so token. We have on. And we already know we have GOTO. So the parser, well, we know we don't do that one. Okay, so if now it's all alphabetical, it's easy for us. Okay, we don't have a case for on, so let's start some tests. GOTO. I may pull these. I don't know. I keep twiddling on these tests, but it's hard to get the picture when they're quite so big. So anyway, let's test. I'm gonna write colon test on GOTO on GOTO. Goes to right place. Okay. And oh well, this is the parse, so that's more of an interpreter test. Test on GOTO. And I'll trust my expression parser. Oh, and we know we do commas already because we did them for subscripts and function. Nope, just subscripts. Oh yeah, and function calls for predefined functions. Okay, and if you get that, I guess we expect an on token, on statement, with, well, we'll need the expression, and then I guess we'll need a list of targets. So the expression is a number 2. And the targets will be an array 10, 20, 30. This should fail to compile. Oh, parse. Actually, I want, well, why didn't that fail to compile? Okay, there we go. I'm gonna go ahead and call it on-GOTO because we'll eventually do GOSUB. I think. Okay, parse does not have GOTO. It needs an expression and a list of line numbers. Yeah, these enums is so much. If you're doing this in C, right, you'd really have to go and write all these routines to handle the subtrees and cases, and just really too much. Okay, and then we know the interpreter is going to complain because we don't have a case for it. Step. Error dot can't happen. And not yet implemented. Okay. Should fail. Unrecognized statement. Oh, cool. Yeah. Commodore 64. Yeah. Unknown statement. Good. Okay. Parser. Okay, if the token is on, and we'll leave the possibility that there's on may handle more stuff. Do on. Well, I think my name maybe should just be on. Do this. Is on a reserved word? I don't know what happened there. Expected. Oh, I always do these. Okay. Okay, so we get a next token. That's the on. And then we need to do the expression. Let expert equals try expression. Okay, and then down at the end, we're going to return an on-GOTO with expression. And let's let targets equal of array of line number equal nothing. Okay, let's see. So I think that should be okay. Cannot find on-GOTO. Oh, this is dot. Okay, I'm not doing anything with the targets. I'm just trying to kind of take a little step here, half a step. Test failed, good. Okay, I think the failure may change. Extra characters at end of line. Okay, yeah. All right. Parser. Okay, so you've got to have at least one line number. So in effect, we're going to look for integer followed by comma integer. And yeah, I think we'll have to do that. We have a structure like this before. Well, here's that. I feel like I don't know. There's probably some more squeezing I could do on this stuff. And yeah, so we'll do something like this. But I'm looking for that case we had with the line numbers. I guess look for GOTO. Yeah, this mess. Okay. If the token is an integer, then we're going to skip the token. We're going to let's call it target. Okay, so the integer target, we're going to save it. And And then I guess this is more like what happens here. Okay. And then we are looking for the comma. Token equals comma. We're going to do a next token. And this again. Now maybe I can, let's flip this around a little. Well, okay, let's get it working and then we'll flip it. Okay, so next token, this stuff. Case integer let target. Case, we need to save this one. Okay, so you've got the expression, those things, and that, okay, that comes out of there, good. This is really the case where we didn't have an integer here. Okay, and I'm just going to throw junk for now. Okay, and let's just, let's see, we're doing on-GOTO. Okay, and this is basic case, well, parsing error if line numbers not seen. Okay, parser does. Missing return now. Okay, good. All right. This should pass. Well, what do I know? On-GOTO. Oh, we didn't find the word go-to. Go-to, otherwise, oh, just the message, I think. Okay, so let me add that as well. Unexpected separator can throw. Okay, on expression, go to, let's move the targets down. Then the line numbers, comma, more line numbers, and that should take you to the end. Good. Okay. Let's get those errors. That's probably a common mistake, and this should be I didn't really read the error message. I probably should. Parser go to. Okay, good. Let's check in what we got. So basic on GOTO. Error if GOTO is missing. And then the next error. On well, missing line numbers is error. Excuse me. Okay. And our message is, oh, well, that's good. That means we're getting to that message. Let's this. Okay. Yeah, okay. I think, oh, well, that should run. There's still another error we're not detecting. Okay, so I want to restructure this a little bit first to make it easier to find that. But the error is if you had, well, let's say you had on go to, well, on one, go to one comma, and you left out the stuff after the comma. It says, oh, it's not an integer, but it doesn't complain that you were supposed to have one. So let's restructure this. So I think I'll use that good old guard case again. Is it like this? Else error. Okay. And our error here is this one. Excuse me 1 second. There we go. Sorry about that. All right. So if we don't see an integer here, we're going to throw this error. And do we still? No, something's off balance. This here was an error. Okay. Oh, I'm still messed up. Do forward, do next. Whoops. Let's undo that. On guard. Okay. Am I balanced? Okay, yeah. So that's better. Really wish it wouldn't relocate you after you do that stuff. Let's find on. Oops. Back one. This one. Okay. Now, okay, so this requires at least one number after GOTO. We skip over that integer, add the target, and now we're doing this here. Okay. But this case is also an error case. If there's no integer there, then we've got another error. Okay. And I think we'll distinguish that error, meaning use a different message, missing a line number after comma. Okay, so if you have 10 comma, ON-GOTO requires line number after comma. Okay, and this test will fail. We'll want this message. Okay, and statement 10. So it just took the 10 and ignored the fact that there was no thing. Okay. I think I can say else. Well, let's do it the same way. Guard case integer let equals token else this drop that. And that was around 240. Must not fall through. Okay, so we'll throw a parser error. And that should pass. So this ratio, one test to make sure it's working, and then 2 or 3 more with errors. That's pretty common for compilers. We like getting error messages when things go wrong, and each one takes a little more work to do. Okay, but I think this is done. Okay. And we'll commit. Okay. That covers the parser. Now the interpreter. GOSUB. Oh, and again, I'm thinking like maybe I should clean up more in my tests. Like, what would be... I mean, I almost want to do like a test per major statement. Maybe that would be the best. And one for expressions. I mean, expressions are a pretty complicated one. Um, let's extract out. Let's make a new file. I'll just do that for now. Parser expression tests. And it's going to pull, it's going to look like this at first. So we'll want this. I guess we'll want that. Okay, and we'll clearly need this and this. Okay, and well, any test that's a check expression and a related error. Okay, so all these. I mean, expressions are kind of a big deal in BASIC. If variable. That looks like a error check on expressions. Def is a new thing. That's more assignment. I think we'll take those predefined functions as a separate one. Okay, these are looking like our statements. That's today's. Okay, let's see how this thing does. Build failed. Oh. Good, and this should still be good. And everything should still be running. 199 tests. Okay, that sounds right. Good. We extract expression tests to a new file. And that's a refactoring. All right, now parser tests, I don't think they need check expression or check relational anymore. Shows you what I know. char parses string. I guess that's okay. All right. That was a good theory. Let's shorten the claim. Maybe they just don't need check relational. Okay, good. And I just want to move check error down below check statement. Below both. Okay. We removed check relational. Okay, that's somewhat better. I'd love to find some way to give that. Like I want to get this method is useful. I hate saying parser test.check statement because it just gets old. All right. All right, I'm not going to do them all. Okay, I got to do a little bit at a time. I just can't stand. We'll sit with that and see how it feels. How's that? Okay. Interpreter. Now we're doing the on-GOTO. All right. We'll check program results. Expecting string. Okay, so if we said 10 on to go to 10, 20, 30, or 20, and 30, print 30. Okay. All right, so 2 should go to the second one, which is 30. It should print to 30, so we're expecting 30. Actually, let me add 15. Okay, just to make sure nothing falls through. And this test should fail. Our NYI, good. Okay. Interpreter on GOTO. This is expression. Okay, so basically we're going to do an evaluation, evaluate the expression. Okay, so let value equals in the global context. We don't we're not a one-liner function, can't do a GOTO. All right, so we get the value, and then well, we're going to spin off another obligation, aren't we? Okay. We've done parsing error this. All right. On-GOTO interpreter, and then it said it was an error if negative, and fall through if not in range. Okay. All right. And let's do this dot as float. All right. Yeah, it's a float. We have to convert it to an integer as well. Okay. Well, we'll just take we're taking the base case, so we just need a line number. Let's take targets, we'll take the int value. I may need an exclamation. I'm surprised I don't. Okay, so if we evaluate it, convert to an integer, and get the corresponding line number. All right, and let's see what this does. I still think I deserve a complaint here somewhere. A failure. Nothing is not equal to 30. All right, let's break here. Let's print that expression. Number 2. Okay. Step over. Let's print targets. 20, 30, 20. Yes. Okay. Int of value is 2. Oh, I'm off by 1. No. Well, I'm off by 1. Okay. This should be int value minus 1. But that let's just keep going. Okay, so step over. Next line number should be set to 20. Okay. That's why I didn't print anything. That's fine, I think. Maybe print 20 might be a better situation. Yeah, let's do it that way. Okay, it printed 20, so it didn't take the right case. I'll put the -1 in because the on statement is 1 based, but our targets array is 0 based. Should pass now. Okay. Okay. But if let's see what Commodore 64 said again. Oh, if it's 0 or greater than its list, it just ignores the statement. Okay. And continues. All right. So with 0, ignores or just goes to next statement. Next line. Okay, so on 0, well, that's probably not wise. All right, so on 0, we expect to just fall through and print 15. These don't have to be unique. And I don't need a line 30. Okay, so 0, go to this, prints 15. If it falls through, it should fall through. And let's do the corresponding too big test. One, 2, 3. Again, should on-GOTO with too large value goes to next line. Yes. All right. And again, both these should fail. Yeah, array index out of bounds. Okay, so we get the value. If value is greater than or equal to 1 and value less than or equal to targets dot count. Okay, so if there's 3 values in there, 3 is legal. Okay. We'll just return, and that'll make us fall through. I'm not sure what the ant is complaining. Move that up. Okay, if it's greater than or equal to 1 and less than or equal to count, then it should be fine. We'll just fall through. Otherwise, we do a GOTO. All right. That should make the first test happy. What do I know? 0. Am I looking at the right test? Sorry, let's check this one. Okay. I'm confused. Value is 0. Let me do a clean. And we'll break here again. Okay. Value should be 0. If value greater than or equal to 1 and less than or equal. Oh. Let's flip it. All right. That's got to work a little better. And continue. Oh, man. What do I know? What's value? Value is 0. Oh, I flipped improperly, didn't I? I flipped 1 instead of making it less than 1. I switched this to. It's really equals 0 or it's greater. Okay. Because we haven't addressed that negative case. Okay. Next one, too large. That should have the same issue. Okay. Next one is negative. I guess let's do them negative, 0, positive. Throws error. We are expecting an error. Just a message. We'll borrow the one from C64. I think that's how it was. No space here. Okay. That should fail. Blow up. Should have thrown error. Okay, good. And the error is if value is less than 0. Again, I'll use the guard just because that's more explicit. Okay. I'm afraid to speak. um, if all right. Oh, how about you do a test with an actual negative value? Okay. Um, all right. Is there anything else to cover here? I don't think so. All right. Let's see what we got. On-GOTO interpreter error negative fall through if not in range. Okay. Let's go down here. Make errors report line and column number. Well, I'm not super interested. I don't think we need on-GOSUB that much. Let me move it down. If relation then statements. I think this is that you could say like then print 3 or something like that. That might be useful. This one I keep talking about. All right, let's look at this one. Parse base errors. Okay, I think we finished GOSUB and on-GOTO, so I feel like we got further than I expected today. And I want to spend some time on cleanup or doing something that's not statement oriented. I think by skipping forward to next line, I think we kind of do that. This, well, stop is interesting because it's sort of a debugging thing. You can, instead of an end statement, which stops your program, you can say stop, which pauses it, and then you can restart from there or run from there. Kind of like a breakpoint. Some of the old interpreters would let you print variables and stuff like that from the command line. So you could stop, put this breakpoint in, print the value of some variables, and then continue and go from there. That might be interesting. Column number, okay. Print has a lot of complexity we haven't dealt with. Spaces without normalization. Yeah, that's another possibility. I think we answered that one no, actually. And that was a couple days back. I think it was Parser Error is better. I think that was here. Okay. I think maybe this is the one we'll tackle next time. So what was the interpreter tests? Test helper for parse-based tests and interpreter tests. Well, let's find parse. You know what's going on here? I think these tests. Well, when we first started, we had more separation that we would. Yeah, how do I want to say this? The parse structure is sort of the interface between the syntax analyzer or parser and the interpreter. So if we check with a parse, then we're seeing, does the interpreter handle this this parse correctly? If we check with code like this, we're 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 coupling the parser to the interpreter to test it. I don't think that's necessarily the wrong thing. As a matter of fact, I think it's actually okay and maybe even better. Like, why do I need all that? Print with relop. I don't even know who's calling this. Okay. Yeah, let's find that. Not very many. Okay, equals, not equal. Okay, we're checking kind of the opposites. The print is practically gone here, right? Okay. Print with. Yeah, I want to change those. Okay. Let's see. Check relop. Print with relop. Okay. I think what we could do is say let program equal 40 print ten. Oh, now I see. Because the token comes in as a token type. Yeah, but that's okay. Let's do op 10. Okay. And then we'll pass the program in here. And then I want this to go away. I want it to really be check program results. Yeah, that's what I want. That. All right, now somebody should complain because I want this to be string. Okay, so I just want you to pass the operator directly. And I guess I'll kick it. Somebody should complain. Where's print with relop? Oh no, there's a complaint. Okay. Cannot convert value. Okay. Op1 expected true is going to be string. And string. Okay. If I build, yes. So now I'm just going to put the string values of these things in. greater or equal and less than. And I think check rel op is really kind of like check opposites. So let's rename that to check opposite relationals. Relational ops. Okay. Check print with rel op. Should be a 1, should be a 0. Okay. And then this, I guess I want to see if it works, but this should go away. All right. Improve interpreter tests. Okay, now who else is doing a parse? Parse 10, statement skip. This one, I think this could be a check program results too. Okay. There was, I mean, we were doing some of these things before we even had the notion of following through to the next statement and stuff like that. So, I think what we want to do is make sure let's see. So this is like 10 remark, skip this line, 20 print 20. We expect 20. All right. So we just want to prove that remark statements get skipped and we just fall through. Okay. Again, before this test, we did this remark statement very early, maybe first. And it made sense to just do the step and try and make sure that everything kind of fell through. Okay. Print by itself. Again, I think we can just check program results. $10 print. And we expect new line. So, I don't know if this first test was simpler, but I think this is definitely simpler. Okay. Now, there might be a case, I think we had a 10 go to 10 kind of thing or something, where it's important to step through instead of just running the whole program, because we don't quite have the notion of a break yet. Check program results. good. Oh, this one's a little... I may leave this one. This one is explicitly building up this tree to make sure the tree is right. Okay, and then we go into these. 1 plus 2 plus 3. I think we can do that. Check program results. Times 6 divided by 3. Oh. Wait a minute. 1 times 6 divided by 3. Whew. Should be hearing little happy beeps. Okay, this one's the one I mentioned. I'm just going to call step. I don't want to just try and run because 10 go to 10 just runs forever. Step will try to go to missing line. Yeah, okay. Go to a non-existent line from the program sense. Okay, that's good. Oh, I just thought of an error we didn't catch. If you GOSUB and then you hit the end of the program and you never called return, that's not legal. Okay, check program results. Let's look for parse. Def stores its function for later. Yeah, that one, I think we're going to have to do that way. A little awkward, but okay, this one we wanted to do that way. Okay. Eliminate most parse-based tests from interpreter tests. Okay. Now, this is kind of, well, it's not really a return statement. It's really almost a characteristic of the end statement. Let's find our end. Yeah, okay. And throws error if open active subroutines, if any active subroutines. Okay, so the program is 10 GOSUB 20. Let's multi-line. So if we check program results, no, this is check expected error program. The error is, oops. Ended program without returning from active subroutine, I guess. This test will fail. Okay, should have thrown an error. Let's get this text. And where's our and statement? I think ironically, we handled that by doing it in place. Okay. Yeah. If return stack dot is empty, this can throw, yeah. So let's say guard. Return stack is empty, else throw. Okay, and run all tests. Okay. Well, this is test cleanup and added test for ending program without returning from all subroutines. Okay. Okay. All right, and then I do want to alphabetize this. GOSUB on. Print. Go to if. That'll get closer. Def should probably be its own method. Go to if assign moves up, def moves up, dim. Assign def dim go to. All right, I want error first, and then assign def dim for end Go sub, go to, if next on, print, return, skip. Okay. What? Okay. Okay. That we did. I think the other refactoring we did was extract parser expression tests dot swift from parser tests dot swift. All right. I'm moving this one up because we just really got to address this at some point, but I think I'm resisting. Oh, I hate seeing that. I mean, I have to do it all, but I'm resisting. Multiple statements on a line. That introduces some interesting problems. Our line numbers are no longer our locations, so we have to do some extra work. Instead of line numbers in my stacks, I'm going to have a line number and like 0, 1, 2, 3 for the segments of the line, I guess, something like that. All right. Straight out use of type string for variable names. That's let's look at that in token. Okay, it's not an issue in token, but parse. We have line number equals int. Let's make type alias name equals string. Okay, so for variable names, define, well, this one's definitely a name. I'll have to look up def. I'm not quite sure there. This one's a name because it's the control variable. Next is the same thing. Let's find usages on this. Function name, parameter. Well, I guess both those are names. All right, and then an expression, string is a string, but variable is a name. Predefined is a name. User defined is a name. And array access is a name. Okay, make sure test pass. Good, all right. Create a type alias for name equals string. Good. All right, and now the parser should use those. Let's find them. Okay, def. Predefined function call, this name is a name. I guess I can just walk through these and pretty much see them. Name is a name. Name type, okay. I'm just looking for anybody who's passing a string. Okay. Parser and then interpreter. Same kind of thing. We'll just see anybody who's passing a string. Output is not, the output is a real string at this point. Okay. Expression array value name here. Store name. And you can see the weakness of the type alias. It didn't report those as errors because it says they're equal, or they're the same type. Understandable, but it's a step, okay? It will mean less change if we pull out our own type. Find next with variable name and do next. Okay, I think that's it, yeah. All right. All right, and I guess the to-do, that we did. Okay. All right, well, that was good progress. So we got both the GOSUB-RETURN and the ON-GOTO working today. Next time we'll tackle this multiple statements on a line, and then assuming we finish that, which I don't think it's too hard, we will handle this write to an output stream. I've just been putting it off, and I know I need to not do that. Yeah, sometimes it's better to just tackle the harder problems and make sure you've got a solution. I don't mind living with something for a little while, but I've waited too long on that one. So anyway, next time is tomorrow, Wednesday. It's 10 a.m. Eastern to 12:30 p.m. or 3 to 5:30 p.m. UTC. And thanks for joining me, and I hope I see you again in the future. Take care. Bye-bye.